This factoring lesson involves special cases, one of them being in my terrible handwriting, the difference of squares. So what that literally means is you're doing subtraction, which is difference between two perfect square numbers or terms. So in the first example, to get to our two binomials, because all of our factoring examples have ended up with a final answer of two binomials, is take the square root of the first term. So the square root of x squared is going to be x, and the square root of 81 is 9. Now, what's going to happen that's special in this case is we're going to have in one of them x plus 9, and the other one we're going to have x minus 9. And if you think back to when we learned about FOILing, this was one of those tricks that we learned where you know that x times x is x squared, 9, x times negative 9 is negative 9x, 9 times x is positive 9x, and 9 times negative 9 is negative 81. And the two 9s, negative 9x and 9x, cancel each other out. So you want to think back to other things that we have done in class before to help understand why this quick process makes sense. So all you have to do is take the square root of the first term, write it down in each of the binomials, take the square root of the second number, write that down, and you're just going to write one as a subtraction, one as an addition sentence. And to show you again how that works, if we take the square root of 16 and x squared, well, the square root of 16 is 4, and the square root of x squared is x. So we have our 4x in each of our binomials as the first term. And then I'm going to go ahead and write 1 is plus, 1 is minus. You take the square root of 25, which is 5, so we fill that in. And you're done. The next example I have is perfect square trinomials. So what that means is the first and last term are perfect squares, and there's something special that happens from those perfect squares to get us that middle term. So to show you what we would do is we would be writing out the square root of the first term, which is x, and the square root of the last term of positive 36 is going to be positive 6. And I know that it's going to be positive 6 because the middle term is also positive. Now in this example, we don't have to write out the two separate binomials because they're both going to be x plus 6. So we just go ahead and write a squared because it's a perfect square. Now also, if you think back to FOILing when we did this perfect square example, what we learned was if we square the first term, which is x times x or x squared, square the last term, 6 times 6 is 36, then to get the middle term, we said x times 6 is 6x, and then we multiplied that by 2 and got 12x, which, as you can see, is the middle term. If you want to write out x plus 6 times another x plus 6, you can. It's just there's no need to do that because we have a shorter way of writing that, which is right here. So this is more of the final answer that I'm looking for. So you just double check that if you took the square root of the first term and the last term and you wrote that down into one final answer, if you multiplied your final two terms together and then doubled it, does that equal the middle term? To show you one more example, we're going to do the same thing with this bottom one here. We're going to take the square root of the first term. So the square root of 4 is 2, and the square root of x squared is x. And then the square root of 9 is going to be 3. Now what I notice is since the middle term is subtraction, I need to put a subtraction symbol in the middle. And that way, when I go to double check my work, 2x times 2x is 4x squared. Negative 3 times negative 3 still equals positive 9. And then if I double check my middle terms, 2x times negative 3 is negative 6x, and we multiply that by 2, we get negative 12x. So those are just a few quick tricks to solve. If you don't like the trick for these two examples of a perfect square trinomial, you don't have to use it. However, the trick is really necessary for the last two questions. So good luck.